Hello students, in this session
Let us solve question of thermal stresses. In this question, we are given with a thin walled cylinder of radius r and thickness t, which is open at both ends. Keep in mind that this is not a closed cylinder, this is open cylinder, open at both ends. Okay? This you should remember. And fits snugly between two rigid walls. Two rigid walls are there and it is kept in between the walls. Right? And Young's modulus E is given, Poisson's ratio is given, Poisson ratio is nu, and coefficient of thermal expansion alpha is given. We have to find out what temperature rise should be there, what is the temperature rise should be there, so that there is no gas leakage. The gas should not leak. When the pressure P is applied, when we are applying the pressure P, what will happen that there is no longitudinal stress developed. Linear stress will be zero because it is open cylinder, and circumferential stress will be there. Only hoop stresses will be there. Due to hoop stresses, there will be shorten in the length of this cylinder. So we have to rise the temperature delta T, so that the shorten in length can be compensated by the rise in temperature, right? Increase in length by the rise in temperature. So we have to find out what is the rise in temperature delta T, so that there is no gas leakage in the cylinder. Right? This we have to solve this question. So let us solve this question.
in this question we are given with a pressure vessel, and this is an open pressure vessel. This is open from here, suppose, and there are rigid walls are there, right? So when the pressure is applied, initially it was at this condition that there was no gap in between there, right? But when the pressure is applied, the gap will be developed in the material. Why the gap will be material? Because this is open pressure vessel. There is no longitudinal stress. Only hoop stress will be there, right? So when we know that at any point in the pressure vessel, there are two types of stress are there. This is sigma L in longitudinal direction or linear direction, and this is sigma H, that is hoop stress. Hoop stress is there, right? So sigma L is 0 because it is open, and open pressure vessel don't have any longitudinal stress, right? So due to the pressure applied, so some pressure is applied. When the pressure is applied, there will be only hoop stress, and there will be no longitudinal stress when this pressure is applied. Due to this applied pressure, the hoop stress will be there, and this hoop stress will cause the decrease in length of this pressure vessel. So total length of the vessel will be decreased by some amount, right? Say delta L. So what will be the, or due to that change in length, there is decrease in strain of this material, right? So compressive strain will be there because this is in opposite direction, perpendicular direction, right? So what will be the strain developed in this material? Then we will come out what we want to find out, right? So in this question, due to this pressure, what is the strain developed in longitudinal direction? So epsilon in longitudinal direction, that is equal to sigma L upon E minus nu is a Poisson's ratio sigma H upon E. So this sigma L is 0 because it is open pressure vessel. So epsilon L will be equal to minus nu sigma H upon E. This minus shows that there is decrease in length of this pressure vessel in linear direction. Now, but we want that the gas which is producing this pressure should not leak from this pressure vessel. So for that, what we have done is the temperature of this pressure vessel is increased, right? And when there is increase in pressure and temperature, say delta T, what is happening? There is expansion in the pressure vessel, and expansion is such that the gap which was obtained due to this case hoop stress, due to that applied pressure and due to this hoop stress, now this gap is filled due to the temperature rise. And what is the expansion due to this temperature rise? So, or the strain due to this temperature rise? So thermal strain thermal strain due to temperature rise delta T. This delta T temperature rise, what is the thermal strain? So that thermal strain will be equal to alpha delta T. You should know the formula, that this is alpha delta T, where alpha is the coefficient of thermal expansion given to us, that alpha. Now if we want that there is no leakage in gas, the change in length, the decrease in strain due to this hoop stress or pressure should be equal to the increase in strain due to this temperature rise. So this longitudinal strain should be equal to this thermal strain, right? So 1 should be equal to 2 for no leakage of the gas, right? So that whatever there is decrease in length, there should be same increase in length due to this temperature rise, right? So we can write that this linear strain should be equal to this thermal strain. So alpha delta T should be equal to mu, we can remove the negative sign, sigma h upon E, right? This can be obtained, right? So what is sigma h? Is the hoop stress, that is hoop stress is given by PD by 2T. You should remember that hoop stress is given by PD by 2T. You have to go to the thin cylinder chapter where you will find this equation. PD by 2T is the hoop stress and longitudinal stress is given by PD by 4T. You should remember this for thin cylinders. So hoop stress is PD by 2T, or in terms of radius, because we are given with the radius of the cylinder. So we can write P R by T, right? Put here, you will get mu P R by TE. Solve it and you will get the temperature rise. Basically we have to find the temperature rise. How much temperature rise is there so that there is no gas leakage. So delta T will be equal to mu PR by alpha TE. So this is the answer of this question. This is the answer of this question, and this is option number C. So this is option C, right? So you have to remember that due to this applied pressure, there is hoop stress developed, not longitudinal stress, only hoop stress developed, and this hoop stress is perpendicular to the longitudinal direction. So there is decrease in length of this cylinder, right? That is given by, because hoop stress is in this direction and longitudinal stress is this direction. So there is gap in between, there will be gap developed here, and the strain developed will be minus, negative, this term. And there is temperature rise. We have to find out what temperature rise should be there. So there is temperature rise so that this gap is filled, this strain is filled by this temperature rise. So due to that temperature, thermal strain is given by alpha delta T, and this strain should be equal so that there is no gas leakage. So this is given by this equation where hoop stress is, this hoop stress is PD by 2T.